The next step in our exploration of the conditional statement used in bash scripting is going to drag us toward actually test the conditional if statement, the kind of which you are already used to do in other programming languages. Okay, so what we've seen so far, we've seen that the if statement in bash scripting is actually intended to run a command and then interpret its error return code as being true, which is 0, or false, anything but 0. Okay, so now that we got that out of the way, what I'm going to introduce right now is going to make more sense. What I'm going to introduce right now is a command. So we know that if statement expect to run a command, right? As part of there where you would put a condition in other programming language. Okay, so what about we run a command named test? So if I do type test, it's going to tell me test is actually a shell built-in command. Okay, so that's fine. All right. I highly recommend that you take a look at the man test, the man page for the test command. Okay, it's going to give you an exhaustive list of everything that this test command can do. I'm just going to illustrate it with a few select examples. So what does this command do for us? Well, I can type test, and then I'm going to pass as argument of this command test, you guessed it, something that I want to test, proposition. So for example, I could say, okay, I want to test if 25 is greater than 20. So by writing test, the first argument is 25, then the second argument is the option -gt for greater than, and then the third argument is 20. I'm instructing test to evaluate whether the number 25, the integer 25, is greater than 20, and return an error code that's going to mean true or false. So I'm going to display this error code, and I use a semicolon here to actually do everything in one line. Okay, so first command executes, and then second command execute, and it's going to display the error code that was returned by the last command I executed before it. Okay, so let's see what we get here. So we get a 0. 0 means the test command executed successfully, and it means that the expression that I asked the test command to evaluate is true. So that's the correct way to interpret this stuff. Now, just to make sure everything is working as we expect, I could put here 25, I could put here 0. Okay, so now I expect this expression to be false, and you can see that the test command indeed returns an error code that is 1, which means something went wrong, which means false. So there are other things that we can use here besides -gt. Okay, so greater or equal, for example. So if I try to test 20 greater or equal to 20, now this time it's going to tell me that's true. Okay, not because it's greater than, because it's equal. So there is a whole bunch of different things, different options that you can use. Okay, so we're not going to cover them all in the video, but I really, as I said, strongly encourage you to read the man page so that you know what's available. The ones that I want to mention in this video, well, first off, I want to clarify something regarding those tests on integer value. So you have different operators. Okay, you have things like, for example, greater than, greater or equal. So you have also lesser than, lesser or equal, and equal. Okay, so for example, I can test if 20 is equal indeed to 20. Now these option -gt, ge, lt, le, and eq, okay, these are meant to compare values. So if I do something like I want to test that 0, 0, 0, 20 is equal to 20, it tells me, well, yes, okay, 20, even if you put a bunch of zeros in front of it, it's still the value 20 as an integer, and it's equal to the value 20 as an integer without a bunch of zero preceding it. Okay, so those option -gt, -ge, and so on and so forth, they are meant to operate on integer values. Okay, now there are other ways to compare things. There's one other way to compare things, which is the equal operator. Okay, so you can use the equal operator here, and you can say I want to compare 20 and 20, but this time it's going to tell you false. That is because the equal operator is meant to actually compare things that are represented as strings. Okay, so and that brings us to a point that I wanted to bring up in this video, that Bash is really testing things based on their representation as strings. So by default, if you try to compare 0, 0, 0, 20 and 20, what Bash is trying to do really is trying to compare this string representation with this string representation. And if you use the equal sign, it doesn't try to think beyond this, it just looks at, are those two things displaying the same way on the screen? Are they the same string? Okay, and the answer is clearly false. Now, if I didn't have those leading zeros, then a string made of the character 2 and 0 is identical to another string made of the characters 2 and 0. Okay, no question there. So what happens when you try to do something like -eq, equal? Okay, well, when you try to do things like equal, then you are telling Bash explicitly, I'm going to give you numbers, okay, and I want you to interpret these as number. So while I'm talking, I'm using a bunch of different syntaxes here that you could come up with, okay, if you wanted to try to find how to break the system. And you can see that every time the answer is 0, true. So no matter if I pass a string like here or here, okay, or if I pass just an integer value, everything boils down to a string, but those strings are then processed by Bash knowing that they represent integer values. So in that case, all of those heading zeros here are ignored, because for an integer it doesn't matter to have a bunch of zero ahead. So those -eq, -gt, etc. options are really there for processing integer value, but the bottom line is that the Bash shall always start processing everything just as a bunch of strings, and that's what shows when you use equal. So in addition to the equal operator, I should also mention the different operator. Okay, again, it's very common syntax. So if you try to say, is 0, 0, 0, 20 different than 20? Well, yes, because we compare them as strings, by using the equal and !equal operator, yeah, these are different. But now if you were trying to compare with eq again, okay, just to confirm, yeah, that would be another story. Okay, these are equal when you compare them as integer. So there are other options that are available. Again, refer to the main page. Things like, for example, -f, I think it is. Let me double check that. No, -e. -e is going to allow us to test if a file exists. So let's take a look at what I have here in my working folder. I have a myscript.sh. So test-e myscript.sh. Okay, and then I forgot to display the return value 0. So test executed correctly, so it succeeded, so it's true. So the file myscript.sh, the -e option allows me to test if it exists. Okay, and you have other options like -r that are going to not only test whether the file exists, but whether you have read permission on that file, which is the case here. Okay, everybody has read permission. So -e, -r, there are other options that work with file like -w, which is going to tell you if you have write permission to the file. -x is going to tell you if you have execute permission to the file. Okay, so a bunch of options again to test whether a file exists and has specific permission for whoever is executing that test command. And then we have things like, for example, -t, which allows you to test whether a file name that you specify, a path or whatever, is actually a folder, a directory. So in this case, yeah, my script is not a folder at all. And then if I go back and I say, all right, let's forget about this and try data2, which I know is a folder, then yes, it's going to tell me data2 is indeed a folder. So we have an interesting command here, test. And we have actually a way to use it right away in our shell script. So we can write things like, for example, if test -d, and then $1 for example, the first argument that you pass to me. So if test $d $1, sorry, -d $1, I can say $1 is a directory. Okay, else, so elif test -e $1 So I'm going to say echo $1 is a folder, and then else echo I am really not quite sure what $1 is. Alright, so basic script, we are using test here in our if statement. So we first test if the argument that was passed to our script, the first argument, is actually a directory, display an appropriate message. If not, we test if it's a file that exists, display an appropriate message, and if none of that works, well, we display another message. Okay, so let me save this. So this is my script.sh. Now let me execute this. My script.sh, so I need to pass an argument, right? I'm going to say something like, well, let's start with a file name, so /myscript.sh. So it tells me my script.sh is a folder, so that's not really good. Okay, so we're going to work on that. If I specify data2, okay, data2 is a directory, okay, and then if I specify something that doesn't exist, I'm not really quite sure what blah 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 is. So what's the problem here with my script? Well, it's simply the error message, okay? What I meant to say here is it's a directory and then it's a regular file. There we go. That makes more sense. So let's try again, okay? So my script.sh on a file name that exists, okay, that's a regular file. Then my script.sh on a folder, okay, it detects it's a directory, and then my script.sh on something that doesn't make sense, and it tells me, well, it doesn't really make sense. Okay, so we're good. So this syntax should make sense now, because now you understood that if is meant to run a command and look at its error code. Test used actually to be an external command. Okay, and it's probably still an external command on some other Unix system. And then it has been replaced by another external command, and the name of that executable was opening square bracket. And now opening square bracket is part of the bash syntax, so that has evolved too. But at some point in time, we add in /bin an executable whose name was opening square bracket. And it was just an alias to the test command. So instead of having to type test every time, you could use an opening square bracket. And the convention was, even though it was not necessary back then, you have to close that square bracket. So nowadays things have changed a little bit. So that syntax is still available, but now this is pretty much integrated inside the bash shell. So you still put here a square bracket, spacing around it, okay? You close your square bracket, and that notation is completely equivalent to the test notation that we have been using so far. Okay, so for example, let's clear the screen here, let's give it a little go. Okay, see, this is still a regular file, this is still a directory, this is still, I don't know what it is. Okay, so it's just another notation. Very few people are going to use the test notation. They're going to prefer to use obviously the square bracket notation that seems a little bit more familiar, okay, but they are equivalent. That's what you need to understand. And another thing that you need to understand that should be clear by now is that if I would have introduced this example first, you would have thought, well, okay, this square bracket here is part of the syntax of the if statement, period. Okay, and you would have accepted that probably without question. Now you know that this is not part of the syntax of the if statement. I can replace this by anything I want, any command I want to execute, as long as it returns pretty much something I can interpret as a truth value. And the square bracket, the test command, are no exception. They are built-in commands, but they are still commands that return an error code, and that error code is interpreted then as the truth value. Okay, last thing we're going to cover regarding this syntax. What if I want to use okay, if I want to use something like this? I'm going to get rid of that elif, okay, and I'm going to say I want to test that this is a directory, okay, and let me check what else we could actually we can do two things like with files rather. I want to make sure that the file exists, and I want to also make sure that I have read permission to it. So the way to do those two tests separately is to use those two test expressions, okay? And now how do you connect them logically? that's going to, you probably already guessed, okay? You're going to use a logical AND operator. So if I write something like this, I can say $1 is a file and I have read access, okay? All right, so again, the logic is really common based on what you learn in other programming language. If I say, okay, let's try that on data2, it's a file and I have read access. Let's try that on my script, it's a file, I have read access, and then on whatever, and then it tells me no, that's not working, okay? So if I was doing something like chmod all minus r data2, okay, then I could give a shot again to that script, and it would tell me that I'm not sure what data2 is, but meaning, you know, it's not a file and I don't have read access, okay? So one thing that could be surprising here is that data2 is a folder actually, and it's displaying here, okay, it's a file and I have read access. Well, I misread those things actually. So the -e means it exists, and it could be a file or a folder, and the -r mean whether that file or folder has actually read access available, okay? So it's a little bit more general. It worked fine in the previous version of the script because I was first testing if it was a folder. And then if it was not a folder, I was saying, okay, well, does it exist at least? And if it exists, I made the conclusion that, I jumped to the conclusion that, well, okay, it's not a folder, it exists, therefore it's a regular file. So we have been dealing into a little bit more detailed version of the semantic of the -e and -r option right here. But then again, refer to the main page, you'll have a solid definition there of exactly what is being tested, okay? What else do we need to cover? So yes, we do the logical AND operator here, so you could do a logical OR operator, but what I want to draw your attention to is also the fact that we do not put those logical operator inside the square bracket. So I didn't write something like this, okay? I clearly separated each test that I'm conducting inside some set of opening and closing square bracket, and then I put the logical AND operator between those, okay? So that should, if I was trying to expand this on the command line, that should be the same as doing test-e$1, and so $1 here I would have to specify, so let's say data2, okay, and test-r and data2, okay? If I write it like that, I'm gonna echo obviously the return code. If I write it like that, the interesting thing is that you clearly see that we are testing whether this thing is true. So we execute a command and look at its return code, and then we execute another command and look at its return code as a true value. Okay? If you think of it that way, and you understand that the square bracket is just a syntactical way to write the same thing but without having to call the command test explicitly, then this is the first test. This is the first command being executed, and then this is the second command being executed. I erased a little bit too much here, okay? So now it makes sense. It's like it's one command, logical AND, another command. It just so happened that those commands are written, you know, using actually the square bracket syntax instead of calling explicitly the test command, all right? So if you understand that, then this notation should make sense pretty fast. If you still think that somehow the square bracket is part of the notation for an if statement in Bash, then you are misunderstanding something. And that misconception is going to come back and bite you in the rear when you start writing things like that and think to yourself, well, yes, that makes sense. Okay, my condition is in square bracket. No, that's not the right way to look at it. The right way to look at it is each test is between square bracket, and each test is a separate test command being executed, so I need to chain them with a double ampersand operator, as I learned to do previously. Okay, and that's pretty much all we had to cover here for that if statement.